Here we have another quadratic equation that we want to solve. Anytime you have a quadratic equation, typically you want to have this equal to 0, especially when you have your x squared, your x, and your constant term. One of the first things you want to look at here is, will this guy factor? After a couple of quick passes on this, you realize that this guy is not going to factor over real numbers using integer values, so we need to try something else. We could try to complete the square. But if you remember the steps to complete the square, you see the first step is pretty simple, to move the 3 to the other side. That's not a problem. Then you have to divide everything by 3, which would give us a fraction here, and you still have to divide by 2 and square that 4/3. It's going to get messy, it's not going to be pretty, so let's not do that. Instead, let's use the quadratic formula. So in the quadratic formula, you need to identify your a, b, and c. Your a, of course, being the coefficient of x squared. Your b is the coefficient of x, in this case 4, and your c is always going to be that constant term. And anytime you want to use the quadratic formula, you want to make sure that your lead coefficient is positive. If it happens to be negative, then divide everything in the equation by -1, and that's going to help you out a whole lot when it comes to simplifying your quadratic formula later. Now, remember that your quadratic formula looks like this. You can even sing the song if you want to. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Anytime you use the formula, you write it down. And now it's just a matter of plugging in the values that we have. So this says -b, which is going to make that -4 plus or minus, now we got the big square root, b squared, well, b was 4, so 4 squared is 16. Now this minus 4ac is a guy that I want to take off to the side, because sometimes it gets kind of messy when I look at it in the formula. So, off here on the side, -4 times a times c, so that's -4 times a, which is 3, times c, which is, again, 3. And -4 times 3 times 3 gives you -36. So minus 36 is what goes inside the radical for that minus 4ac. So we just kind of work it out here on the side, and it kind of keeps us from getting in trouble. And this is all over 2a. A is 3, so 2 times 3 is 6. Now you need to be careful here. It's very tempting to try to reduce the 4 and the 6, but we can't do that yet. Understand that the 6 is not only the denominator for the -4, but also the denominator for this radical. So let's keep simplifying this and see what happens. We have -4 plus or minus the square root. This gives me -20 on the inside, still over 6. Now we need to reduce this square root of -20. Remember that we break this down into its factors. We can use -4 times 5. 4 is a perfect square, and of course this negative here means I'm going to have to pull out an I. I have to pull out the imaginary unit. So this is -4 plus or minus the square root of 4 is 2. The square root of the negative gives me the I, and then I have 5 that's left inside the square root. And this is all over 6. We see here that everybody here has a factor of 2, so we can reduce by the common factor of 2, and that gives me a -2 plus or minus I times the square root of 5, and this is all over 3. Now this answer is perfectly acceptable to me, but we do want to understand that since we do have a complex number here, you may be asked to separate this. So if you have to separate this, using your set notation, you would have this: -2/3 plus the square root of 5 over 3i, and the other solution is still a -2/3, and now minus the square root of 5 over 3 I. Now typically we would put the I in front of the radical like what we have here. That way it doesn't look like it's inside the radical, because if you stick it back here, sometimes depending on your own handwriting, it may look like it's under the radical, which is wrong. But when I separate it here, and I've got this fraction, I put the I on the outside of the fraction so it's clear to see that the I is not inside the radical. Of course, let me make sure I close off my set notation. So these are the two answers. These are complex, which means if you go back to the original problem, there's no way this guy would have factored. For two reasons. One, you end up with solutions that are imaginary, and two, square root of 5 is not something you would have gotten from factoring. So, to recap, use the quadratic formula, be careful with all of your signs, make sure that you do reduce correctly, and then simplify if you can.